Hello guys, so we're going to be talking about triangle congruence here once again. Alright, so let's look at the first one first. CB is congruent to FB. So we are looking at this line segment is equal to this line segment. Now, BT, which is small line segment right over here, that portion is also equal to BA, which is this small line segment. And BB is equal to the other side, TS. Now, DC is congruent to here, FS. Now, we want to prove that angle D has to be congruent to angle S. Alright, so when you look into this, where would you draw the triangle that we want to prove to be congruent? If you look at carefully, you will realize that this triangle DCT might be a nice choice. So I'm going to try to mark it here. It seems that this one would have been a nice choice. In fact, but we have this small piece, CB, and also BT. We have individually congruence with the other pairs. So we probably have to use the addition postulate. So as dV, and then VT here, you can see that that's reflexive. Now, then let us try to write this one up together. So first, statement right here. And then here, regions. Now, first will be the given statement. So, given that, you can write all these things right over here. And the reasoning will be given. Now, let's get started with number 2. Since CB is congruent to BT, if you combine them together, then we will end up getting CT. You see, CT must be congruent to FB, which will be the corresponding sum here, FB. And those two would have been congruent to each other because of the addition postulate. Alright, now, so we talked about one pair that's already given, second pair which we added them up together. You see the blue VT. You will realize that VT, this one has to be always stated because it was mentioned. VT has to be congruent to VT by reflexive property. Now, we will be needing reflexive because that VT is part of the both triangles. Given that we're going to have DT must be congruent to SV. Now, once again, there will be addition postulate. Now, with that, what we have done is we compare 3 pairs of the corresponding sides. Then, we can say triangle DCT must be congruent to triangle SFV. And the reasoning behind that would be because 3 pairs of sides, hence we're going to write down SSS postulate. Now, number 6. Since these 2 triangles are congruent, you will realize that each corresponding parts must be equal to each other, which one of them being angle D and angle S. So angle D must be congruent to angle S. And the reasoning which we can write will be the cpctc, meaning corresponding parts in congruent triangles are congruent. Once again, corresponding parts in congruent triangles are congruent. That's basically what we're talking about here. Alright, let us look at number 2 together. So in order for us to write this one up, PR is congruent to TB. PR, this small line segment, is equal to TB, which is another small line segment here. Angle 1 and angle 2 are also congruent to each other. Now, and also TQ, which means this whole line, entire line segment, I'm going to just highlight over, right over here. TQ also must be congruent to UV. Now, then, can you imagine two pairs of, the pair of triangles which we have to prove to be congruent? Because ultimately what we have to do is, we have to prove that angle Q is congruent to angle U, right over here. How would you do it? Alright, so first we have one pair of sides given. Second pair of sides seems to be quite nice, but except that we have this small portion common. So whenever we see the overlapping triangle with the common line segments, we can easily prove that the additions of those two pairs must be equal to each other. Addition postulate right over there. Now, another thing is, since this angle is congruent to that angle, but angle 1 is in fact outside of the triangle RUV. But by vertical angle, you will realize that this angle is also congruent to this one. All right. So let us write this one up together. So here we have statement. And regions. All right, first one. First one will be all the givens. So I'm just going to put it over here. And then the reason being it's given. Number 2, as we mentioned earlier, RT is congruent to RT. And second one, the reasoning behind it will be reflexive. Of course, anything is equal to itself. Now, number 3. So addition will be also equal to each other. So therefore, PT must be congruent to RV. And the reasoning will be addition postulate. Step number 4. So now we have 2 pairs so far, but you will realize that another thing is angle RVU is congruent to angle 1, because as you can see, the vertical angles are congruent. All right, number 5. But as we realize, this RVU is congruent to number 1, but angle 1 was congruent to angle number 2 from the given. So therefore, we get to realize angle RVU must be congruent to our angle number 2. Number 5. In fact, this is like a chain rule idea, which is called transitive property. Transitive property basically says when one thing is equal to another, and the second thing is equal to the third one, then first one must be equal to the third one. That's what it means. Number 6. Now, since we have written down all the necessary conditions, one side and angle between them and the other side, so now we can say triangle PTQ must be congruent to triangle RVU. Number 6, between side angle side, because angle was used between those two line segments. Then we can say number 7. Angle Q and angle U would be congruent to each other. And then the reasoning once again becomes cpctc. Alright. Let us move on to number 3 now. Starting from number 3, what we have to do is we need to fill in the blanks. So for example, number 2, angle A is congruent to angle D, and you will realize that this came from EA is parallel to DF. As soon as you realize that two lines are parallel, then we need to figure out the other properties that goes along with the parallel lines. And then BE is congruent to AD. BE is congruent to AD, so we realize that this portion is also right angle. Now CF is congruent to AD once again, then this portion is congruent to each other. Now, number 2, why is it that angle A is congruent to angle D? Because that's an alternate interior angles. So alternate interior angles are congruent in parallel lines. Now, number 3, perpendicular lines formed by congruent right angles. Now, that means we are looking at angle EBA is congruent to angle FCD. Now, many times we have written this statement into two different parts. Perpendicular lines create right angles, and all those right angles are congruent. But in this case, they put it into one. So, but it's not a big problem. Now we have angle AC, or line segment AC is congruent to BD. Now that was part of the proof given. That means we're looking at this portion is congruent to the other portion. But as you can see, there's a overlapping area right over here in the middle, CD. So that was given before, and BC is congruent to BC, that they will be reflexive. Now, right after that, number 6, as you guys can see, we are looking at subtraction postulate right over here. Then you will realize that those two triangles must be congruent by this side is equal to, oh no, actually it will be what? That portion is equal to this portion. Then we get to realize those two triangles are congruent by angle side angle. And BE is congruent, which is this line, this portion of line segment. And CF is also congruent because of this portion. Then we end up getting, it will be CP, CTC. All right, let us look at next question. Once again, same, plugging in the statements and reasonings. So here we have angle C is congruent to angle I. And AC is parallel to IK. AG is congruent to EK. And GI, that's a question mark, has to be congruent to EC. Now, once again, I want you to look at this picture for a second, because all I have done was simply marking it based upon givens. But do you realize that this middle portion, GE, is overlapping between those two triangles? And GE is congruent to GE, which I'm going to just write down reflexive already right here. They should be equal to each other. And the number 5 would have been addition postulate. All right, number 2, angle A is congruent to angle K. Once again, because of the parallel lines, we can write alternate interior angles. are congruent. In parallel lines, number 3, AG is equal to EK. That was given. And those two triangles are congruent because of the one side and another side. One side, and where's the second side? Oh, these are the parallel. So therefore, when they're parallel, we get to realize angle A must be congruent to angle K, which was written right over here, which we didn't write it here. So therefore, what we are looking at is angle and another angle, angle, side. And then therefore, at the end, we can write down GI must be congruent to EC. And that will be cpctc. All right, let's move on to the next question. Last question here. So this is a straight line, PQRST. And R is the midpoint of QS. That makes this line segment equal to this line segment. And angle 1 is congruent to angle 2. This one is congruent to angle 2. And angle U and V, we need to prove that angle U and V are congruent. So QR and RS is congruent. That will be given. That will be not given. From given, we have the midpoint. So therefore, a midpoint divides line segment into two equal parts. Now number 3, supplementary. 1 and 3 are supplementary, and then 2 and 4 are supplementary. We can call it a linear pair. Meaning these are the pair of the angles which makes up a straight line, hence the name linear pair. If angle 2 is if two angles are supplementary to the same angle or congruent angle, they are congruent to each other. In this case, we must be looking at angle number 3 must be congruent to angle number 4. URQ. URQ. This angle then must be equal to this angle. Why? Because the vertical angles are congruent. Now, those two triangles are congruent by angle side angle, so we have triangle Q UR must be congruent to triangle SVR. And then those two parts are equal to each other by cpctc. Alright, so this is the second part of the homework. Have a nice day. I'll see you guys later.